Hey everybody, welcome to today's webinar. Excited to have everyone here. It's a great topic, orchestrating multi-agent voice AI systems. As some folks are trickling in, I'd like to first introduce the speakers for today's webinar. First, we have Teresa Foy. She is Staff Technical Product Manager here at Deepgram. We also have Jake Lasky, Senior Applied Engineer. So they're gonna kick things off in just a moment. I'd like to let everybody know that if you guys do have questions you'd like to ask, please direct your questions to the Q&A section of the webinar platform. We'll try our best to answer as many questions as possible, but we'll also have time for Q&A at the end. So don't worry if we don't get to your question. We'll try to get to it at the end of the session. In addition, there's going to be a couple of poll questions that pop up. We'd love to get your feedback on via those poll questions. And one other thing I'd like to mention as well, this will be viewable on demand. I know that's a question a lot of folks ask. So there will be a recording. It will be viewable on demand afterwards if you're interested in that. So with that, I would like to go ahead and hand things off to Teresa to get started.
All right, everyone. I am really looking forward to this, and I just wanted to come on, and we'll go picture in picture briefly, but just wanted to additionally introduce myself with a few more details. Like Hassan said, I'm the technical product manager who owns all of our voice agent products. Today, that's our voice agent API. We'll go over that a little bit briefly in the middle of the presentation, but also I work on our speech-to-speech research, and eventually that will become part of our voice agent platform as well. So while we're talking today about multi-agent voice AI systems and what that looks like, would love to continue engaging with all of you for any other types of voice agent questions, and specifically about our voice agent API or what the future might look like. Really excited to be here and get started on this. Jake will be handling along with Hassan a lot of the questions in the Q&A piece as we go through this, but when we get to the Q&A session at the end, we'll be able to go through things verbally with all of us here. So looking forward to that, and we'll get started from there. All right, and a quick agenda. Today, we're going to explore what a multi-agent architecture is and why you should use them, along with what some of the common voice use cases are for those multi-agent systems. Next, we'll go through our best practices, and they'll showcase how you can avoid some of the common pitfalls that we see in a multi-agent use case. And last, we'll explore what those look like when we put them into practice through the architectural deep dive, and we'll finish again with our questions. So what is a multi-agent system? And this actually zooms out to think about all types of multi-agent systems, whether that's through a voice agent or otherwise. But essentially, these are multiple specialized agents, and they work together to achieve these more complex outcomes. Some of the structures that you see are more like an assembly line. Some of them are more collaborative, like groups working together. But essentially, multiple agents are coming together to be able to accomplish those more complex tasks. And the big feature here is that each agent is independent. So you're able to do things like change LLMs among agents based on their relative strengths. And you can utilize smaller and ideally lower latency models for those simpler agents, again, looking for that lower latency outcome there. Or you could easily showcase transferring to a more specialized agent by changing the voice. So there's a lot of optionality depending on your use case in a multi-agent system. What of the benefits of these systems are you'll see an overview here on the screen, and we'll talk more about what you can accomplish using these multi-agent systems. So first is accuracy. Here you can see that agents can cross-check each other's work, and they lead to more accurate results, especially because each of them are tasked with more specific jobs they can become better at. Efficiency. Your agents can work in parallel, so this also speeds up the task completion. For example, you could have one agent speaking while another agent takes notes and summarizes. Next is task handling. So, instruction following and task handling is one of the biggest things that voice agents need to do. Here, you can have larger tasks broken down into smaller, more manageable subtasks, and each agent can focus on a specific aspect or a few related aspects. Scalability. The system can be scaled easily by adding more agents with these specialized capabilities. So, whether you're building kind of a single agent that is more, or a single agent platform that's looking to solve a specific problem, or you're kind of like a voice agent application that might need many agents for many customers, you can see that there's scalability across either of these dimensions. Next is fault tolerance. Not something that we talk about a lot when we're doing these kind of big demos, but agents can fail. Whether your LLM fails, whether you're just seeing some server side problems, if one agent fails, now you have other agents that can take over its responsibilities, even if they weren't necessarily designed to fulfill the exact use case. You want to make sure you're still continuing a conversation no matter what and not leaving your end customer hanging. And then last, thinking about kind of hallucinations and bias. So, by combining the perspectives of multiple agents, your system can reduce the effect of hallucinations and bias, which will lead to more reliable and trustworthy output. So, you want to make sure that you're able to use a system that can continually improve the outcomes for your end customers, making sure you're reducing any of these potential error pitfalls. Moving on to some common voice multi agent workflows. The first we have here is we're looking at healthcare triage. So, what this might look like is a patient calls into a telehealth line. They want to report some symptoms. They're not sure if they can just get a prescription over the phone, if they need to go to the doctor. And so, we've broken this down into three potential multi agents that you might have. The first being a symptom collector. So, they're going to gather structured data from the patient in natural conversation. The second piece is the medical reasoner. So this will map the symptoms that to these possible conditions using a knowledge base. And the third would be a care coordinator, providing the next steps like booking an appointment or escalating to a more emergency line. Another version of this could be kind of just a typical customer support with tool use case. An example here might be customer requesting to reset a password or checking their account balance or any other of the routine pieces that you might see in a typical customer support interaction. Here, the breakdown would be first a conversation manager who keeps the interaction flowing naturally. Next, the tool invoker, who behind the scenes is actually handling those API calls. And then the summarizer or the memory manager, which creates that structured summary of the conversation for the ticketing platform that customer support might use. With those things in mind, let's move on to some best practices that you'll see how we illustrate when we move to our example. So, the first is defining agent ownership. A common mistake that we see is when people define agents by what they can do instead of what they own. You want to make sure each agent has exclusive authority over a decision or an artifact so that it's very clear. Some examples that you see on the left of how to do that is owning conversation intent classification or owning external API calls to a billing system or whatever systems you have. On the right side, these are the descriptions you'd want to avoid. So these are more capability based, handling customer questions or does summarization. If you were thinking about summarization in a more authority or ownership model, you might say completes a summarization at the end of a call and exports it to a system. So there are ways to accomplish this using this more authoritative stance. The next is routing and control. So the kind of rule of thumb here is no agent should directly invoke another agent, and you want all requests to go through a controller. Depending on your orchestration framework, so you might be using things like a pipecat or a live kit, you might be using an API like with Deepgram, or more of a full-fledged product like something like VAPI. This might be implemented in different ways. You might see it as kind of an independent orchestrator, or it might be another agent entirely. So you see kind of different patterns depending on what's supported in the products that you're using. And last, we want to make sure that we're having audible transitions so that as your agents hand off between each other, it's very clear that the conversation is moving forward and continuing with that natural rhythm you'd expect with any human conversation. So, an example of a success phrase would be I've started the refund, a failure phrase, I can't access that right now, and an escalation phrase, I'm going to bring in a specialist. So, making sure that you're providing this information along the way so that your end customer knows exactly what's happening. Let's move into a detailed example that uses Deepgram's voice agent. These patterns, like I said, are things that you can emulate in other products, but I'll get started by doing a brief overview of how the Deepgram voice agent API works. So, our voice agent, what we think about is how we can emulate human responses kind of in all capacities. So, we are thinking about it listening, thinking, and speaking naturally and in real time. What we have are really gracefully handled interruptions as we have kind of first of its kind end of thought detection modeling. We have this independently for some of our older speech to text models that are all of our Nova models. And we also leverage our newest model, Flux's embedded end of thought detection and prediction. So we're making sure to maximize this developer control, allowing you to choose between these models, but making sure that you have all of the conversational management and orchestration handled inside the one API in the blue box that you see on screen. Alongside the control there, we also want to allow builders to choose between open source, closed source, and bring your own LLMs. And we support multiple TTS providers that we'll speak about soon. We power voice agents across industries. So we have AI intake agents that collect patient information, similar to what we discussed earlier. We can securely verify caller identities or answer transaction questions in financial services. And we handle a ton of routine customer service questions like resetting a password and even power drive-through ordering with really consistent upsells. So this platform is something that's quite flexible to whatever your use case might be, and happy to answer any questions about that at the end. We want to make sure that you're choosing the tech stack that fits your needs. So on the speech to text side, you can choose any of our Deepgram speech to text models. On the LLM side, we have Deepgram hosted LLMs from OpenAI, Anthropic, Google, and Grok. This allows you to use our hosted models and we just pass along specific cost to you. It's not token based, it's still just usage by the minute and the hour. With Amazon Bedrock, you can bring your own API key, but we support that with a deeper integration, as well as allowing you to bring your own custom LLM. On the TTS side, we have our Deepgram TTS models. We also have a Deepgram hosted instance of Cartesia, which is similar to our Deepgram hosted LLMs, where it's all in one cost and we can just absorb that and pass it on to you. As well as you can bring your own TTS with OpenAI, 11 Labs, Cartesia, and AWS Poly. Transitioning into the use case that we'll discuss here, we focused on sales and lead qualification. So you can imagine that this is either an inbound or outbound call that gains information about a potential leads for things like a plumber or a moving company, but this could apply to many different types of businesses. First, we have a qualifier agent, and the qualifier agent does the initial contact and the lead qualification, collecting the name of the end customer, their location, and any needs that are specific to that business. It has specific functions that it can invoke, which is to hand off to the next agent or to end the conversation. From there, there's an advisor agent. This provides consultation and recommendations after it receives that summary from the qualifier. So it's able to actually say, hey, we think you'd be a good fit, or yes, we have openings. Here are all of the things that you might do to enrich that conversation. And the functions it can invoke are handing off to the next agent or ending the conversation. And last, our closer is someone who's going to schedule any follow-up and gathers feedback after receiving a summary from the advisor agent. So it's able to say, yes, you're a good fit. Yes, we'd love to take you on as a moving client. Yes, we want to schedule that plumbing consult. So it'll do things like schedule follow-up, record the satisfaction of the end user, and end the conversation. So you can see here that each of these agents has the specific functions that it owns, and this illustrates that best practice of the authority over these specific functions and artifacts rather than just a description of what we want to do. We have this as a sequential bit of specialized phases, and this implementation demonstrates how to overcome some of the challenges that you might see as complexity grows in a traditional single agent system. Each of these conversational sequences has a specialized phase and state with its own system instructions, its own transform context that's summarized from the previous agent conversation, and then those specific tools or functions. Not everything is going to be best in a sequential set. In some of our specialized use cases that we saw earlier, you saw that there's more background agents who are handling tool calls and foreground agents who are handling speaking. But this is an example where you have a sequence of steps to go through, and all of the agents can both converse and perform function calls. Here's how this kind of leverages those multi-agent benefits more specifically in this context. So context management, each agent will start fresh rather than accumulating the entire conversation history. So this helps cut down on, again, on some of those hallucinations and bias that you might see. It also makes things faster. They all have focused responsibilities. So agents will excel at their specific tasks instead of juggling everything. This helps to narrow what they need to be experts at, again, minimizing that latency and upping the success that we see. Next, better reliability. Fewer functions per agent means clearer decision making for the LLM. Again, how do we narrow the scope so that the LLM can perform at peak condition, making sure that we can actually accomplish what we want to do in the most efficient path? And last, easier debugging. Issues are isolated to specific agents and transitions. So if something goes wrong, you're able to really narrow the focus rather than going through an entire voice agent and understanding where it might have gone wrong. And then you're able to actually provide those changes in a more specific context as you move through an implementation. Looking at the architecture that we have, there's a few kind of like key points that we'll move through. Starting on the left, we in our sample, we're using a Twilio phone call that has a persistent WebSocket connection, and this is going to be our audio stream. This is a really common pattern where telephony is the audio source for voice agents, but this would also work just as well if you were having a voice session through a web app or a mobile app or something like that. So that provides the audio stream that starts a voice agent from there. And that is persistent. The Twilio WebSocket and the audio forwarding task will remain active throughout the session. Next, we have the call orchestrator. Again, this is that best practice concept of having a centralized orchestration. We don't want agents communicating and handing off to each other directly. And what this does is it actually performs that central coordination and it manages all transitions and state. Inside this is the audio forward task. This is the persistent task that keeps the voice agent call going while we hand off among the agents over time. Then we will see that there's the three agents that we just discussed here, the qualifier agent, the advisor agent, and the closer agent. The orchestrator can communicate with all of them, as well as being able to pass through the sequence that you see illustrated through the arrows. And then on the right-hand side, you'll see this context transfer. So we chose to use a small and fast LLM through the Grok API that summarizes conversation between the agents and allows for that really clean handoff. Going into deeper detail here about this central orchestration and the transitions. Again, we said this implementation creates separate voice agent sessions for each specialized agent. So part of the Deepgram voice agent API allows for really easy bringing up and tearing down of voice agents and still being able to maintain that phone call consistently. The call orchestrator manages those transitions and maintains that Twilio connection through the audio forward task. The orchestrator does a bunch of things. It summarizes the current conversation using the Grok API. It closes the current voice agent session, but keeps that audio task running. It will start a new voice agent session with that summarized context. So as you're closing down the qualifier and then you're bringing up the scheduler, for example. And then last, it continues the audio forwarding to the new agent seamlessly. So making sure this feels like one conversation, no matter if you have 2 agents or 25 agents underneath the hood, this is a pattern that you can continue to use from there. And this is actually a repo that is available now for multiple agents. You can get started today. If you're using the Deepgram Voice Agent API, you're able to kind of simply go and get started really quickly. But that repo is available for anyone to look at if you're using other products to emulate these patterns. If you're not using the Deepgram Voice Agent API today, but you're interested in, you can sign up for a free account, and there will be $200 of credits in there to help you get started and play around with what this implementation might look like for your use case. And with that in mind, we wanted to move into some of the questions that we have. So I will head over to our Q&A section, and we can start answering questions from there.
Okay. I'm also gonna come back on, so I will read some of these questions out to you, Teresa, and Jake, so
Great.
that you guys don't have to go through the Q&A. Okay, so this is from Joshua. It says, "We need this service, but the agent must be able to speak Danish. Would you be recommend your solution together with 11 Labs to ensure high quality?" We're already in
Yeah,
contact. To be sure.
yeah, absolutely. So I'm just going to zoom back a little bit to this thing here. So the what's nice about the um, Deepgram Voice Agent API is that you can use our SCT models with Deepgram TTS or with other TTS providers, depending on what your needs are. That being said, and so in this case, if you were focusing on Danish, you would be able to use 11 Labs TTS, or if there was a specific 11 Labs voice that your customers needed, you would be able to use that. That being said, language expansion is a massive research and product effort right now at Deepgram. We actually just announced 5 new languages for our TTS last week, and we have more coming very, very shortly. I am the product manager, so I don't want to overpromise on timelines, but I can tell you that we are in the evaluation and productionization phases. So you can kind of imagine this in the more weeks timelines for more voices coming. Hassan, not sure if you have a specific update on Danish there.
Not a specific update on Danish on the TTS side, but we're gonna have a significant expansion in our language support for TTS in Q1, so stay tuned.
Awesome.
Okay. Um, Here's a question from Rahul. Is there a rule of thumb for when to split into agents from a function call count standpoint?
I don't think there's necessarily a rule of thumb because each is going to be a bit specific to your use case, but generally the smaller your agents are, the faster they will be and the more accurate they will be. But like in any microservice system, you are now adding complexity to the system overall, and you need to make sure that your orchestration among them can really handle all of that complexity there. So I think not necessarily best practice, but you can see when you're building like very large agents that have many function calls that does add to some of the challenges you see. We started with about 3 per agent, but I think it's good to have some experimentation there. I certainly would not go into double digits.
Okay. This question from Jaywan. Can we set the rule-based LLM orchestration?
What does rule based mean to you? If you can either add something in the chat or
Yeah, we can come back to that one in case if we can add some more color to it. Here's another question from Kimia. Since each agent starts fresh, what is the solution in case the user wants to refer to the previous conversation with the agent to complete a task? Will there be some kind of short-term memory?
Yeah, so the way that we think about this is we use this context summarization here in order to make sure that the context from the previous agent's conversation is passed to the next agent. So having this context pass through will help make sure that your agent is aware of what happened and they can refer back in order to progress the conversation forward, no matter what your end customer wants to refer to.
Okay, another question from Ralph. How do you handle new user input while one of the agents is still thinking?
New user input. I'm going to interpret this as like the user wants to kind of like change directions. They might have like asked to schedule something, and no, actually they want to cancel an appointment or something like that. So I think the most important thing here is that your agents understand what their boundaries are of like what they can do and what they can't do. And so in a world where the user is now requesting something else, you want to make sure that the agent is aware that this is outside of my scope and how to actually hand off to the orchestrator in order to do that. So thinking about kind of going backwards to our best practices. So defining these verbal exit conditions will help allow for those transitions to be very smooth. Jake, not sure if you have any other kind of like tips or tricks to add on the engineering side there.
Yeah, it's really important to leave these voice agents as effectively state machines. And so if you have so as the agent listens, it can also be thinking, and those things should be able to be done in parallel, in the same way that right now you all are listening to me speak and you're thinking about what I'm saying, and I'm thinking about what I'm saying, and I'm speaking. But these things are done in parallel, very similar to the way that people interact with biological systems like our own brains.
Okay, here's a question. How do you handle long conversation memory in these types of systems?
I think one of the things that we're thinking about is like actually how do you reduce some of the context that you might need to continue accumulating. Obviously that can one drive up your pricing depending on what product you're using, but it also can make things much slower. I think one of the benefits of these multi-agent systems is that while you're getting the context summary from that we've designed here, you also have the ability for each agent to start fresh rather than accumulating that entire conversation history. So it kind of balances between those two things and helps leverage kind of like the strengths of starting fresh while maintaining the context from going on. Jake, not sure if you have anything to add there as well.
No, I think that you answered that perfectly.
Okay. One question from Ayub. How can this architecture facilitate a multi-language service which is able to detect the language on the fly and carry the conversation accordingly?
Yeah, absolutely. The way that I would think about this is rather than looking at like a qualifier agent, or maybe even you could think about qualifier as understanding like, hey, what language do you speak? So in a traditional IVR, you might have press 1 for English, press 2 for Spanish, press 3 for French, or whatever it might be. You could actually imagine that being your first agent that says, hi, I'm Teresa. I speak English, French, and Spanish. Like, how would you like to respond to me? And so that this agent's job is only to give this greeting, and then its function is to detect the language that is spoken back to it. From there, it can actually set the next agent with a specific language and speak to it from there. So that's the approach that we're seeing a lot of people take. Depending on what models you're using, you might also have a multi-language capable STT and TTS model. And so you might not necessarily need to do that language detection, and you could just say, hey, we support these 4 languages. And if it's not one of those 4 languages, you can kind of like give a sign off message of like, oh, we don't actually speak that language, but we'll follow up via email or something like that. But that's the architectural choice that we typically see is like the first one's responsible for greeting and detection, and then it helps set the next agent's language specifically from there.
Okay, here's a question around latency from Kalyan. For a voice agent which works over a phone call, what is an acceptable latency for a response? So using SCT, TTS, LLMs, vector database, app hosting from different providers, how reliably can we achieve the low latency?
Yes. So this is a requirement that is for your end customers. What we see typically is that about a second and a half, so 1,500 milliseconds is typically where there is a breaking point where people won't wait any longer than that. We want to be much lower than that. But of course, the bottleneck there is your LLM. For really, some of these more complexities, it's going to add significantly to the latency. our voice agent API does minimize the latency among these products, and it really works to do those things. When we're thinking about speech to speech in the future, low latency is something that we're thinking about. But generally, what we see among our customers is 1 to 1.5 seconds is acceptable in the typical like sales or customer support use case. That, of course, is different for everything, and we, of course, want to be lower than that. As we do it, with the bottleneck being the LLM, having these more specific tasks and these narrowly scoped agents helps really minimize the thing that can balloon that to 3 seconds, 5 seconds, and becomes very clunky and unhuman-like.
Question from Redwan. How does the caller's input get processed while they are still talking? Do the agents monitor the transcription stream? What if the most vital information is at the end of the caller's sentence? Would the processing restart?
Yeah, that's a great question. So looking at how the voice agent API works under the hood, essentially the STT transcript is developed and then is actually recorded, and then that is what's sent to the LLM. We have a product called Flux, which is our newest model that's designed for conversation. And what this does is, in order to understand and predict when a turn might be ending, it's actually capturing them, at the word level, and then being able to actually send that to you with a prediction of, do we think this is the end of the turn, and then sends a finalized transcript at the end. So it kind of is a best of both worlds. You're able to take, if we think something is close to the end of the turn and you're trying to minimize latency, you're able to take that transcript as is and send it to the LLM. However, then if you received a finalized transcript that's actually different, you can actually override with the new information that came at the end of the turn and send that to the LLM and have it action that instead. So I'd recommend using Flux in that use case in order to actually get the benefits of both. Those knobs are things that you can tune depending on what your end customer's tolerance is and what your kind of like business stance is on either being faster or being more positive about the outcome of the transcript.
There's a question from Tyler. What does parallel agents under the hood look like? So, for example, one speaking, one taking notes. How are their outputs orchestrated?
Yeah, I don't have a great visual for this, and Jake, I'll turn it over to you in case you have a better way to illustrate this. But I'll go back to what this might look like is, if the conversations manager's job is only to actually do this, rather than having like an orchestrator that's handing off between agents, you might have both of them running in parallel in the background. You just know that one of them is only responsible for outputting to a central note repository, and that's the only function that it will do. It does not invoke a TTS at all, for example. So you can orchestrate this in a couple different ways. Jake, I'll kind of turn it over to you in case there's any specific ways that you want to explain the implementation side.
Yeah. The other thing that I wanted to just mention is that these centralized repositories that Teresa's kind of mentioning, there should be that orchestrator there is an orchestrator that's looking at all of the answers and all of the things that the speakers and the note takers and all of these other function callers, they are all adding additional context to those centralized repositories. And then the orchestrator is deciding, based on what information they are providing, what should come next. So there is one brain that's kind of orchestrating all of this, and then all of the other systems are feeding into that.
Okay, another question. This one's about an integration. So we already have a system which is a multi-agent system powered by Google's ADK. How can we plug in Deepgram into the system and have a voice-to-voice solution? Just a couple of follow-ups. What would be the best practices to get this working? Any caveats and pain points? Not sure if we have an integration available.
Yeah, my understanding about the ADK is that it itself is kind of the product that you'd be using to actually create your voice agents. So you can think of these as either like competitors or different choices that you would make. You would either potentially use our voice agent API or you would use Google's ADK. So it kind of depends what is going to fit your use cases the best. Obviously, I'm partial to our own product as the product manager, but we want to make sure that it fits your use cases best. So happy to follow up more specifically to see if there's a fit there, if that's something that you'd want to continue talking about.
Okay. Aside from partnerships with Twilio and Amazon Connect, do you have a list of proven integrations to telephony systems, or are there any other integrations available?
Yeah, so the way that we think about an audio input is that it can come from really anything. And what we're trying to do is just making sure that you're able to open a WebSocket with your audio source. So we have really clear examples of how to do this with Twilio, how to do this with Amazon Connect, but any product that can open a WebSocket is able to do this really easily, and we can demonstrate that. So happy to kind of like go into more detail. We are working on more specific integrations, both on the telephony side and through some SBC partners. We're talking to a couple of different providers. So depending on what your telephony use case is, if you're more on-prem and going through an SBC or more cloud telephony providers, but overall, the voice agent product should support this so long as you can open that WebSocket connection.
Here's a question from Fanon. Is there a feature where the agents are able to remember a previous customer, where the agents can draw to some history context of that specific customer?
I love this question. This is like very smart, very business minded, and this is really aligned to what we are thinking about for how we want our voice agent products to evolve over time. So the same way that a human can look back on your enterprise's relationship with a customer, we want to make sure that our voice agents have an understanding. In a healthcare use case, someone might be calling about a prescription refill, but you know that they have an appointment coming up. You want your voice agent to be able to remind them about that appointment down the line. And that's not something that a lot of voice agents are doing today. There are a couple ways that you could think about doing this, which is like having a function call happen at the beginning of a session. So once you understand who that end caller is to have a function that, goes to your CRM system or whatever it might be to say, hey, get the summarized notes of the last 5 calls, or tell me what the history of this customer is over the past week, or does this customer have anything coming up in the next XYZ weeks, and kind of developing what the right context for your business is for a voice agent to have, the same way that a human would be able to look at a system and see that context. You would be able to do that as a function call at the beginning. This is something that is on our roadmap in a more structured way for next year in 2026. And that would be both kind of like your business context. So, what is the health of this person? Do they have those appointments like we just talked about? But also potentially audio context. So do I pronounce my name Teresa or Teresa? And how are you able to incorporate that into your system really easily, both kind of like ahead of time when designing it and at runtime as soon as I pronounce my name within the call. So that's how I'd recommend doing it now, but definitely more to come here. Very excited to continue exploring this.
Here's a relevant question from Krish. Do you think the orchestrator increases latency on the user side since it continuously runs in the conversation?
Jake, maybe I'll turn it over to you since you've done some more of the implementation side here. But the goal with the orchestrator is that it's more running in parallel, other than when it is actually being called to actually pass the conversation on to the next agent. When we're looking at latency trade-offs, of course, any step in a process is going to add latency, but we see that there's far less latency when trading off between agents and the orchestrator than if you need one giant agent who needs to be able to access very many function calls of very large LLMs to complete its job. So we'd rather take very small latency increases in the orchestration than actually like within the agent itself. Jake?
Yeah, and this goes back into like the parallelization of tasks versus the serialization of tasks. So like Teresa, Hassan, and I are all, making this presentation right now, and we're all looking at questions and answering and making, and so each one of us is able to offload a task to someone else, while the giant orchestrator in this case is, this SQL event, right? That is actually doing most of the actual orchestration. And so it's the same exact kind of thought process and design as we're managing these life cycles of these orchestrators. It's the orchestrator is able to do, say, hey, like we just heard this key term, or we just heard something that's actually important. We're going to send out this pre-flight, this pre-flight loading of some database, and so the orchestrator is adding a little bit of latency, but it's two parallelized tasks so that the user's latency is ultimately much lower than if it were just going all in serial.
Great question. Question from Anthony. What are the most common questions you get from customers implementing your voice agent API? What are the most common needs and wants, etc.?
Yeah. From a use case perspective, we see the highest adoption across the kind of like sales center and contact center or customer support use cases. So that's where we see the majority of the adoption. And that's where, in the market, we see the majority of adoption for these use cases. I think next tier down, you see more of the like assistant or like internal tool type use case. And of course, we are an enterprise product. So we are more focused on business use cases than, building a more consumer personal assistant or things like that. So that's one thing to couch when we're talking about what our customers look like. From a question standpoint, a lot of people want to start with that audio stream. They want to make sure they understand exactly how to do it, and connecting to a telephony system is primarily where they get started. But overall, we tend to see more questions in the back and forth around the prompting and how people might actually achieve the outcomes that are there. And we have pretty rich community options for being able to get resources and talk about best practices. So we have a Discord, we have Slack channels for startup call our startup community, where you're able to kind of like work with each other, but also work with us. And depending on your company size and what they're doing, we have applied engineers like Jake who can help do any advise on any of the integrations or how you might do it. So we have a lot of opportunities for you to be able to get those questions answered, even if they're not common. Or even if they are common. So those are a lot of the things that we think about and kind of like work through with our customers on a day-to-day basis.
Okay, I'd say we have time for just a few more questions here. This is from Rahul. For those of us using a platform like LiveKit, what would be the advantage of switching to Deepgram? My understanding is LiveKit has a backbone network to make sure audio packets remain within their network. They recently eliminated the Twilio hop and also host agents in their cloud. Does the Deepgram voice agent platform address this too?
Yeah, so great question. There are different kind of like strengths and weaknesses for different options, and a lot of it depends on both your use case and how kind of like the expertise and the staffing that you have in house. Generally, we see that companies with kind of like larger ML teams or more AI expertise do very well in a platform like LiveKit, and you can do a lot of customization. You can do a lot of work within the platform to achieve the outcomes you want. Of course, like as Deepgram, we are partners with them. We provide our models to them. We have like very close working relationships with them, and we want to make sure that like if that's a good fit for you, we want to make that work for you very well. From a Deepgram voice agent perspective, like we can guarantee the best latency when we're working within our own product ecosystem. So like you will always get the most tuned experience, the most specialized experience, and the most optimized experience when you're using our product. And so it really depends on what is kind of like the best use for you and what your business is optimizing for. The worst thing I could do is to say like, use Deepgram voice agent. It's the best thing out there. And then you get on and are disappointed. And I want to make sure that this is a great fit for you. I'm not in sales, I'm a PM. And so understanding kind of like what your needs are. And we're happy to kind of talk through those things through some of those channels that we talked about to see if it would be a good fit and going from there. As far as does Deepgram voice agent address the Twilio hop and host agents in their cloud? we think about this like probably a little differently than LiveKit. So when we think about kind of like a partnership with Twilio, there's a couple ways that we do this. So when we think about hosting agents, there are a couple of ways that we host them. Either we host them in our own data centers. We also have kind of like underlying cloud partnerships with multiple providers. We have it with Amazon, we have it with Google. I'm sure many of you remember the somewhat recent AWS outage that affected many companies. It didn't affect Deepgram, and that's because kind of like redundancy with all of this is extremely important to how we think about this. We want to make sure that no matter what, our hosted agents and our other products are always available to you. We also have other hosting options where we can do self-hosted. So within your own infrastructure. And then we have something called Deepgram Dedicated, where we can kind of set up a virtual private cloud within Amazon in order to do that and kind of manage some of the deployment pieces for you. So we have some options for hosting there. And depending on, and we have a kind of like a deeper partnership with Twilio. So depending on kind of the mix of hosting needs and what you're looking for with your telephony, we have some options there. I'm happy to talk through those more specifically depending on your use case.
Okay, great. Question from Monique. Does context summarization take tool calling into account? For example, what if a tool call returned 10 IDs, and the user picked one, and we need to refer to that one ID in an agent further down the line?
So it would take the outputs of a function call into account. So depending on what that was, that context would be passed through, in our case, through this context summarizer that you see here and provided to an agent when we do that kind of like orchestration handoff between those. So depending on what exactly, it won't necessarily do that out of the box, this exact agent, but you would be able to use Deepgram's function calling to do that along with the call orchestrator from there.
Okay. Question from Anthony. Would love to talk more about LLM bottlenecks. What models do you see have the lowest latency?
Yes. So we see that the Gemini Flash models tend to have the lowest latency, which does not. That is a latency only description. It doesn't necessarily take into account how good it is at instruction following or how great it is at, say, something like addresses. So if we tend to see the lowest latency there, it's very snappy. From our customer point of view, we see kind of like the simple majority of our customers using the OpenAI mini models. So 5 mini, 5.1 mini, 4.1 mini. And so kind of that is around the size of LLM that people are choosing. We have some customers who are started on this multi-agent journey, some who are still in more of a single agent, kind of like their first agent that they're trying to get out and deploy. So as you move into more of a multi-agent architecture, you are able to use smaller and smaller models that have fewer parameters and therefore can be very fast, but also can still have the specific instruction following that you're looking for and achieve the outcomes that the agent needs to. So that's the nice thing about being able to use this architecture, is you're able to really capitalize on this without needing any more. A lot of kind of a more common way of thinking about this is you can think about like GPT-5 as like a PhD, 200 billion parameters or more, even more than that. You don't often have a PhD person answering your frontline customer support. And so a smaller model is often more appropriate for that first greeting or that first thing there, and it minimizes the latency. So that's kind of the trade-off.
Okay, great. Question from Andre. What modes does call orchestrator support? Sequential, parallel, mixed, loop, or other?
Jake, do you want to take that? I
Sure.
want to make sure that I answer this completely.
Yeah, for sure. Yeah. So the idea here is that the call orchestrator can do all of these sort of modes. This is an infrastructure layer, and so the idea is that you can build out however it is that fits best for you. We generally don't suggest using sequential modes because you end up getting blocking actions that usually add latency in like unnecessary ways. And so the parallelized mode is usually best, but there are times when you'll want to be very sequential. For example, in some sort of like user identification. Hi, what's your name? What's your phone number? Okay, great. Now let me go on to the next. And then you can start doing the pre-flights and everything, but you don't want to be pre-flighting anything unnecessarily because your system may not be able to handle it if you're getting a bunch of calls and they're spam calls. So there are ways you can add gating in order to reduce load on your system, but generally you're trying to increase the number of parallel processes that are going on to make the user's experience really, really good. But ultimately, we support them all because we're an infrastructure layer. Python supports, for loops and while loops and all of the things. And ultimately, this is exactly what we do too.
Okay, we have time for one more question, and stay on, Jake, because this is to you. This is from Aiden. So this is around your response around covering orchestration latency. So if it happens a few times in a conversation, users will feel it. It starts to sound like a filler and erodes trust in the experience. So 2 follow-ups. So beyond the acknowledgement phrases, how do you avoid these stalls when routing takes time? Are there patterns that feel more natural when repeated? And then also you mentioned pre-flight lookups based on keywords and interim transcripts to prepare answers before the user finishes. Would love to hear more on how that works in practice. How much can you reliably infer from partials?
Yeah. This is a really it's a really good point, because in most conversations, if someone were to ask a question, you wouldn't answer it with the exact same tone and the exact same answer, even if you're just saying, yeah, give me a second. The LLM is usually able to be a little bit more creative in the same way that we can. But yeah, it's one of those things that you want to design your workflows in a way that allows for users to have the lowest number of these, yes, give me a second patterns, because you want the user to have the fastest experience throughout the entire flow. And at some point, the actual person who's going through this sort of conversation is going to start getting frustrated if there are a lot of those breaks. And so that's where just good design takes into account. And I did mention the pre-flight lookups. So in the case of our models, so we have interim results that come in not just through our Nova 3 models, but also through our Flux model. And the Flux model includes those interim results at like less than 100 milliseconds of latency. And so those are usually very accurate when you're looking for specific keywords. And so in practice, it works pretty well because you are looking for, it could be something like, yeah, hey, I have a problem with my order. As soon as you say problem with your order, something like that, that's when that pre-flight lookup can happen. And most people are not speaking efficiently. Like I'm not right now, right? You already know that I have a problem with my order. And also, I was wondering if, okay, cool, you can, and so these steps can essentially be queued so that okay, this person has a problem with their order and they're going to have this other thing. And so the more information you can get from the beginning of a conversation, the more you can get the user to speak, the better, because ultimately you can have more pre-flight, those sort of pre-flight lookups and fewer of those. And that will then ultimately lead to less of those acknowledgements phrases, because you have so much basically information that's just ready to go.
Okay, awesome. I think we're at time for Q&A. So I wanted to kind of conclude the session here. You'll see a CTA pop up. So if you guys want to talk more with our experts and just get more, consult around your particular implementation of voice agents, please feel free to contact us using the CTA or from here, or even just go to our website and click contact us. Someone will reach out to you. Thanks, Teresa and Jake, for a great session, great Q&A, great content around multi-agent voice AI systems. As a reminder, we'll share a recording of this for on-demand viewing after we're done with the session today. That'll also have a lot of questions were around the GitHub repo for the multi-agent setup. So you can reference that for that URL. So thanks everybody for joining today. It was great to have you, and looking forward to the next webinar. See you guys.